Hello learners. Welcome to another lesson from Smarth.education. Today we're looking at activity 3, still on the center theorems. We're going to do about 7 questions and then we'll be fine after that. Now, I want you to try the questions that I'm going to give you. You try to do them before I explain to you and then you mark your work. Okay, let's try that. Let's try that and see if we're going to understand. Right now, let's look at this question. What does it say? I want you to read the question, pause the video and read the question and try to answer it. Right, O is the center. Okay, what comes to your mind? O is the center. A center theorem, remember. Okay, which ones are the center theorems? A line drawn from the center, perpendicular to the chord, bisects the chord. A line drawn from the center to the midpoint of the chord is perpendicular to the chord. An angle subtended by an arc at the center is 2 times the angle subtended by the same arc at the circumference. Okay, which one do you think we have here? We have a line that is drawn from the center and perpendicular to the chord. Do you see that? This is perpendicular to the chord. We have a line drawn from the center and perpendicular to the chord. Okay, right. Remember I said you must look at the information before you even look at the question. Right. Then it means, so AC, chord AC is divided into 2 equal parts, meaning that BC is equals to AB. Right. We're given that OP is 6 units, that is there is fine. We're given that OC is 10 units, that one is there is fine. Right, and then OP is perpendicular to AC, we can see that. Calculate the length of AC. It becomes very easy for us to understand this now, once we've done that, because we know that BC is equals to AB. Let's write that one down. Right, AB is equals to AC. Y is, AP is equals to BC. AP is equal to BC. Why is AP equal to BC? Because it is a line from a center, right, perpendicular to chord. Right. Line from center perpendicular to chord will bisect the chord. So now it means we can find BC, and then after finding BC, we can multiply BC by 2 to find AC. So we can say that therefore AC is equals to 2 times, because AP is equals to BC, so it's going to be 2 times BC. Okay, let's find BC. So what type of a triangle is OBC? What type of a triangle is that? It is a right-angled triangle. And then we see a right-angled triangle, think about the Pythagoras Theorem. Okay, right, now what does the Pythagoras Theorem say? The hypotenuse squared. Our hypotenuse, how do you see the hypotenuse? It is the side opposite the 90-degree angle. I don't want to use the longest side because sometimes we have these funny diagrams which are not drawn to scale, isn't it? Right, remember that. So a side opposite the 90-degree angle, which is this side here, opposite the 90-degree angle, that's the hypotenuse. So it's going to be OC squared is equals to OB squared plus what? BC squared plus BC squared. Why is OC squared equals to OB squared plus BC squared? Because of the Pythagoras theorem. Because of the Pythagoras theorem. Right, Pythagoras, okay? So now we can substitute what we have here. What is OC? Is 10 squared is equals to OB, which is 6 squared, and then plus BC squared, right? And then this is 100 minus 6 squared. 100 minus 16 is going to be 84. Okay, right, okay. Is it going to be 84? No, let's see. Yes. 6 squared is 36, sorry. 6 squared is 36. Why do I get 16? So now, or to avoid such mistakes, you do this. Just transpose your 6 squared this side, bring it this side, becomes 10 squared minus 6 squared is equal to BC squared. Right, and then square root. Just put this thing in the calculator. 10 squared minus 6 squared is equals to BC. We have square rooted both sides here. So the answer from a square root is positive or negative. So it's going to be positive or negative 8 here, positive or negative 8. But remember, BC is a distance, so we're going to say BC is equals to 8. You see that? So BC is equal to 8. And then when we answered the question, check that. Because sometimes we've done all these calculations and then we think that we have answered the question, while we haven't answered. Okay. So now what you do, we are looking for the length of AC. Okay. So we haven't answered the question. Therefore, AC is equal to 2 times 8. And then it's going to be 16 units. Done. Right, we're done there with the first one. Okay, right. Did you get it right? Right, let's hope so. Let's hope so. Right, now let's move on to the next part, the next question. Okay, right. Now O is the center. EO is root 3 is given. EO is root 3 is given. OF is 2 is given there. You can see that units, and then OE is perpendicular to DF. Calculate the length of DE. Okay, it's almost the same like the one we just did. Right, can you try to do it on your own? Let's try. Right, welcome back. Did you try? Right, let's see. What can you say about there's a line drawn from the center perpendicular to the chord? The line drawn from the center perpendicular to the chord. What does that line do? It bisects the chord. It divides the chord into 2 equal parts, meaning that DE is equals to EF, right? Because line from center perpendicular to chord. Line from center perpendicular to chord, right? And then what we do after that? What we do after that? Okay, let's say now you did not get this. Now you have an idea. You can continue. You can even pause the video and continue. Okay. So every time, every step is I'll be giving you a clue. Okay. Right. Don't wait for me to do everything for you. Okay. Right now, so we're saying DE is equal to EF. So it means when we find EF, we have found DE. You see that? Let's find EF. Right. Then triangle FEO is a right angle triangle. So we go back to our Pythagoras theorem. What does it say? The side opposite the 90-degree angle here is OF. So OF squared is equals to EF squared plus OE squared. Now, why are we saying that? Because it's Pythagoras. Pythagoras. You see that I'm starting with the Pythagoras theorem. I know some people will just go straight away to say EF squared is equals to OF squared minus OE squared Pythagoras. It's still fine. It's still okay. Right. Now, let's substitute. OF is going to be 2 squared is equals to EF squared plus root 3, square root 3 squared. Okay, now square root 3 squared is 3, remember that. Okay, so it's going to be 2 squared minus square root of 3 squared is equals to EF squared. Okay, if you check here, this is 4 minus 3. 3 is 1. 4 minus 3 is 1. Square root of 1 is 1. So you can even put in the calculator. Let's say you're not sure. Just put it, but I've told you the answer here is going to be 1. Right? Square root both sides. Even this side, if you square root EF squared, there you get EF. Right? So EF is going to be 1. We discard the negative 1 because this is distance, remember. This is distance. So we say EF is equal to 1. And then, but remember we said what? What did you say? We said DE is equals to EF because line from center is perpendicular to chord. So now DE is going to be equals to 1. DE is equals to 1. Unit. Is it unit? Yes, unit. 1 unit. Okay. 1 unit, not units. 1 unit. Okay. Perfect. Okay. Are you going to get the next one? Let's see. It's not going to be difficult. Very easy. Okay. Right. Read the information. Okay. Try to answer the question. And then after that, you play the video and mark your work. Let's do that. Right. Welcome back. Learners, what did you do? O is the center. Where is O? Here. This is O. O is the center. PQ and AB are both chords. Can you see PQ? I can see it here. This is PQ and this is AB. Both these ones are chords of the circle with OM perpendicular to PQ. We can see that. And OC perpendicular to AB. I can see that. Right. OM is 5. Where is OM? Okay, yes, it's 5. I can see this 5. OC is 7. I can see this 7. And AB is 48. Calculate the length of the radius of the circle. Which line is the radius here? I can't see any radius, okay? But now, so I need to construct. Let me construct. What can I construct here to create a radius? I can construct OA, and then I can construct OB. I can construct OP. I can construct OQ. You see that? All these are radii. And then OA is equal to OB is equal to OQ is equal to OP because why? They are radii. Okay, so what are we looking for? We want to find the radius. So we can find any of these ones here. So now this side is 7. I want us to use this triangle, the rectangle triangle. And then what would be AC? What would be AC? AC is going to be 24 centimeters. Do you agree with me? Why is AC 24 centimeters? Because of the line OC. OC is drawn from the center and is perpendicular to AB. So it divides AB into 2 equal parts, meaning that this one is 24 centimeters. This one also 24 centimeters. Do you see that? Okay. Now we have the 2 sides. We can find OA. Right now we can say, what can you say? AC is equal to 24 centimeters. Why did you say that? Line from center perpendicular to chord. Okay, line from center perpendicular to chord. Right now, and then we can use our Pythagoras theorem here. Okay, because this angle also is what? Is 90 degrees, okay? Right, now, OA squared is equal to what? AC squared plus OC squared. You see that? Now, because if you find OA, that will be the radii. So it's going to be OA squared is equal to 24 squared plus OC. OC is what? OC is 7. Let me write 7 there. Let me erase this one. Okay, it's going to be 7 squared. It's going to be 7 squared. Right, 7 squared. I'll need a calculator for this one. Can I do it without a calculator? I don't think so. Where's my calculator? Right, okay, I'll try to do it without the calculator and see, but you can confirm that. Right, now, so it's going to be what? It's going to be OA is equal to the square root of 24 squared plus 7 squared. And then if you put this in the calculator, you get that OA is equals to 25 centimeters. So OA is 25 centimeters. Makes sense because OA is the hypotenuse. It must be the longest side. It must be the longest side. Do you see that? Okay, right. Now we've managed to find OA there, which is the radius. So it means OA is 25 centimeters, OB is 25 centimeters, OQ is 25 centimeters, OP is 25 centimeters. Do you see that? Because all of them, they are radii. Now, same question now. It says calculate the length of PQ. Okay, right. Now, we got that this one is 25. Let me erase this and draw a nice thing. Okay, this one, otherwise it will be clumsy and then we won't manage to see what we're doing. Right, let me use the dotted line. Right, this one is what? Is 25 centimeters, okay? It will be the same as, let me draw this side. You say it is the same as OQ. So OQ is also 25 centimeters. Okay, so they say find PQ, and then if you find PQ, if you find MQ here, we can multiply MQ by 2 to get our PQ. Remember that, okay? Because MQ is equals to PM. Why? Because line from the center, and what? Perpendicular to chord. Okay, it will divide. It makes MQ and PM the same there. So now this is 5, isn't it? Or M is 5. We can find what? We can find MQ using the Pythagoras theorem. Okay, so now let's say OQ squared is equals to OM squared plus MQ squared. All right, okay. What is OQ? OQ is 25 squared is equals to 5 squared plus MQ squared. Right, and then we can transpose 5 squared here, say 25 squared minus 5 squared is equals to MQ squared. Right, and then if you do that, you're going to get, try to use your calculator. I'm going to get a set here, right? Square root this, 25 squared minus 5 squared is equals to MQ. I've square rooted both sides. So it means this is 10 root 6. Okay, it's 10 root 6 is equals to what? Is equals to MQ. If you answer the question, let's go back to the question and check. If you answer the question, no, we're supposed to find the length of PQ. So PQ is equal to 2 times MQ, okay, which is equal to 2 times 10 root 6 is going to be 20 root 6. You can leave your answer like that, 20 root 6, okay, but if you want to write it as a decimal, it's 48.99, but you can leave your answer as 20 root 6 and then centimeters, okay? Perfect. Let's move on to the next one. Oh, this is the last one. No, we still have one more after this. Right, now, I want you to try this one, read through the information, and then you try to answer the question. Let's try. Right, welcome back, great learners. Welcome, learners. Right, let's continue. Let's do it together now, and we'll be marking our work. Maybe it's going to be difficult. It wasn't difficult. The first part, there are 2 parts of this question, you'll see. Now, determine the radius of OB in terms of x. Now, if you check, how many radii do you see here? OB from the center to circumference, from the center to circumference, from the center to circumference. Do you see that OE looks longer? You see that? But actually, OE, OB, and OA are equal because the 3 of them are radii. Do you see that? Okay, right. So now OE is what? Let me write this first. OE is equal to OB is equal to OA. Why? They are radii. They are radii, 3 of them. So we can see that OE is 8 plus x because OD, we're given that, ED is 8, and then we're given that DO is x. Okay, so now we can say OE is equal to DE, ED plus OD, which is 8 plus x. So this whole thing, the radius, is 8 plus x. So we can write 8 plus x for all these radii. Okay, even for what? For OA. For OA, we can write what? We can write 8 plus x, isn't it? So this will be 8 plus x. This also will be 8 plus x. You see that my 8 is not looking nice. Let me try. Okay, right now. And then, so we know that OE is equals to OA. Okay, you see that? So now we can, what can we do here? This is 8 plus x, okay? But now we can find OA in terms of 12 and x. Do you see that? And then equate it to this because they will be equal. Do you see that? OA is 8 plus x. But let's find OA using the Pythagoras theorem because there's something I forgot to mention. What is this angle here? What is this angle here? So let's say angle and then this angle here. I forgot to mention this. Right? Let's say angle ADO is equal to what? It is equal to 90 degrees. Why? Because line from center, what? Line from center, perpendicular to chord? No. Line from center, okay, to midpoint, okay, to midpoint of the chord, of a chord. It's fine. Okay, right. So line from center to midpoint of chord. Right, now we see that. Now this angle here is what? Is 90 degrees. A line drawn from the center to the midpoint of the chord is perpendicular to the chord. Remember that, okay? So it means this angle is 90 degrees. Meaning that, therefore, triangle ADO is a right angle triangle. Right angle triangle. Do you see that? Angle triangle. Okay, right. Now, we can say, now let's use our Pythagoras theorem. So OA squared is equals to, let me put the values once, it's going to be 12 squared plus x squared. Why? Because of Pythagoras. Okay, right. Now, what is OA? Right, OA is equal to square root of 12 squared plus x squared. Right. Now, what did we say about OA? We said OA is equal to what? It is equal to 8 plus x. So we can equate this to 8 plus x. Do you see that? We can equate this to 8 plus x. Right. So, right, let's do that. Okay. So now we can say square root. Let me draw a line here. I will try to fit everything here. Right. Let's say the square root of 12 squared plus x, the line must go up to there, is equals to 8 plus x. Now, what do we have here? We have a set equation. Do you remember the set equation? Set equations. How do we solve set equations? How do we get rid of this square root sign? We square root both sides. So it's going to be 12 squared plus x squared is equals to 8 plus x squared. We can do that by the side. You can expand 8 plus x squared. Some of you know how to do this thing in a faster way. How do we deal with square? These are called what? Square binomials, okay? Right, you just say this squared, which is 64, and then say 2 times 8 times x, which is plus 16x, and then you square the x, you get what? You get x squared. Remember that? Okay, you get that. But let's say you don't remember it. You're going to say 8 plus x times 8 plus x, okay? And then you do your FOIL. You distribute. 8 times 8 is 64. 8 times x is plus 8x. X times 8 is plus 8x. And then x times x is equal to x squared. You see that we're going to get the same thing there, okay? So now we can say, let's go back here. We're saying here, so it's 144 plus x squared is equals to 64 plus 16x plus x squared. When you're solving equations, remember that if you have two terms that are the same, they are opposite the equal sign, you can just cancel them. Do you know that? Because this and this goes. If they are the same with the same size, because if I transpose and bring x squared this side, it's going to be negative x squared, and then x squared minus x squared is 0. So we remain with what is 64 minus what is 64? 144 minus 64. Okay, if I remove 44 from 64 here, I remain with 20. So I can say 144 minus 44, which is 100, and then I can say, and then 100 minus 20, which is 80. You see that? But use your calculator. It's on that I did not bring my calculator here. So this is 80 is equals to 16x. And then what we do to get x? Divide both sides by 16. Do you see how interesting math is? Right, 16 this side, 16 this side, 16 into 80. What is 16 into 80? 5, should be 5. 5 times 6 is 30, 30 plus 3 plus 5 is 80, yes. So x is equal to 5. What was the question? Determine the radius OB. I've answered everything. What have I done here? I've answered everything. Sorry, learners, but now, okay, I've answered everything for you. This was the answer for us. This was the answer here for this question. It says, determine the radius OB in terms of x. I got too excited, but it's fine. It's fine. I really hope that now you can do this. You can do this. Let's go to this, to the next slide. Okay, our answer here was 8 plus x, isn't it? Our answer was 8 plus x. And then the next slide now, I want you to do everything that I've shown you here, okay, to answer this. It says, hence calculate. We say this one is 8 plus x. This one is 8 plus x. It says, hence calculate the length of OB. Okay, I want you to try it, and then you must get what? You must get your 5. Okay, you must get your 5. Remember how we did this? So now you can try it, and then if you want to mark your work, you go back there and then just rewind the video and then check the solution and mark your work. Let's do that. Okay, right, well done, well done. Now let's do the last one. Right, read the information and try to answer the question. Let's try. Welcome back, learners. Right, AB is a chord of the circle with center O. AC is equals to CB. Do you see that? It's given. Do you see this? It's given. Let me pick a red color because it's a bit clearer, I think. Yes. Right. So, right. You see that? Okay. AB is a chord. Can you see the chord? Yes. AB is the chord of the circle with center O. AC is equal to CP. We can see that. And the length of the radius is 5. The radius is 5 units. And then AC is 3 units. And OC is 5 units. You must know this Pythagoras combination. Show that OC is perpendicular to OB and explain why OC passes through the center. Okay, right. Why OC passes through? Where is OC? Because it is perpendicular to the chord. Okay, it is perpendicular to the chord. Right. Okay. Okay, this one it will pass through the center because it will be perpendicular to the chord and also bisecting the chord. A line that is perpendicular to the chord and bisecting the chord will pass through the center of the circle. Okay, right, remember that. So now, how can we prove that this O1 is 90 degrees? Or how can we prove that O2 is 90 degrees? Okay, O1. Now we can use the Pythagoras theorem. So we have the left-hand side is equal to right-hand side. So if these two sides are equal, then it means that right angle is what? Sorry, that triangle is a right angle triangle. So we have the left-hand side, which is OA squared, and then is equals to AC squared plus OC squared. Right, now let's check if these ones are equal. So this one is 5 squared, and then plus 4, AC is 3. Okay, let me just, it's fine. It doesn't matter. It doesn't matter. Remember, addition is commutative. Right, it's equal to 3 squared. Okay, right, it's going to be 25 is equals to 16 plus 9 is equal to 25. Okay, so you've seen that left-hand side is equal to right hand side here. And then we can conclude and say that this is this is what? A right angle triangle, because the hypotenuse squared is equal to the sum of one side squared plus the other side squared. Okay, when you add the other side squared with the other side squared, you'll get the hypotenuse squared. Okay, that's the Pythagoras theorem. So therefore, triangle ACO is a right angled triangle. And we can say, is it C? C1 is equals to 90 degrees. Okay, right, looks like an O. I think it's a C there. Right, okay. So now we've proved that C1 is 90 degrees. And then we're saying now, this line OC is perpendicular to the chord and it bisects the chord. Therefore, it passes through the center of the circle. Okay, right. I really hope you learned something, learners, and we are going to continue with our lessons on center theorems. And then after we're done with center theorems, we're going to go to the tangent theorems. Don't miss the lessons. Make sure you check our lessons on our channel, YouTube channel, and subscribe and learn more. Even you can send us your email if you want extra lessons. You can get more information from our website. Please do contact us and get extra lessons. Okay, thank you very much, learners. We're going to meet in the next lesson.